Hello?
Yes, sir.
Yeah. Once again, good afternoon. In continuation of last class, we discussed about integrity constraints. Correct? In the last class, we discussed about integrity constraints. Basically, in database designing, we have 6 categories of integrity constraints. We already discussed about this. Hello? Sir, no. Some disturbance is coming. Okay. Now we already discussed about this integrity constraints. Yes or no on relation. Hello? Hello. On Thursday we discussed about integrity constraints on the relations. Yes or no? No one is responding. Is this my voice is audible? Hello? Is this my voice is audible?
Yes, sir.
Yeah. Then we discussed in the last class integrity constraints. Yes or no?
Yes, sir.
Yeah, that is the key constraint. Means when we are going to design a primary key, how it will be react, how to create a primary key, and not null, and foreign key constraint, domain key constraint, foreign key constraint you know very well, and domain constraint. Domain constraint is nothing but a data type, and a column constraint, you know, same value we have to give the same order of columns. Then user defined constraints. User defined constraints are nothing but triggers we discussed earlier. General constraint. The general constraints is nothing but sometimes age, and age maybe the age everyone age is 0 to 100 only. If we give more than 100 also it will take. That is why you need to provide constraint. Or maybe uh, mobile number, always mobile number 10 digits, or PAN number or other number. So like that, the generalized constraint. As a user, we need to analyze the data. Based on that, we can fix up the constraints on the relation. Okay, all these 6 constraints we discussed in the last class with example. All of you clear all these constraints? All of you clear this? Hello? All of you clear
Yes,
about
sir.
this constraint? Yeah. Now coming to the enforcing integrity constraint. Now we defined constraints. Now after defining of constraints, here how it is going to enforce these constraints. Enforce nothing but action. Here how it will be done. Here you know, the coming to the primary key initially, if we fix one column as a primary key, maybe the student table, if you take the student table SID we fix as a primary key. Here at the time of insertion or maybe the updation, first of all we'll go with insertion. Here already one SID is 17 7 or 125 123. Now already it is there. Now again we are trying to insert same SID value, then our primary key is going to enforce that the data is already existed. Already we are aware of this enforcing of primary key. Yes or no? Already we are aware or not? If we are not aware, I will show you. Already we done this enforcement of primary key. Hello? Already we verified, right? So when we fix one column as a primary key, even though same data we are trying to insert, then again it will be show if you want to insert, it never accept your data. Yes or no? Already we know that. Hello.
Yes, sir.
Otherwise, I will show you again. Already we already executed same thing earlier, even though I am giving the idea again. Courses. Okay. Courses. Please, all of you following. All of you following.
Yes, sir.
Yeah, this is student. Your SID is the primary key. Now, just I am writing displaying of data query. Select star from students. Yes. Now table is there. Now 18 7 are 1 to 1. Your SID, these are the SIDs. If I want to insert into table name, now I want to insert again 18 7 are 1 to 1. Just I am typing the data. Date of birth. Next one is what? Phone number. Next one, mail ID. Mail ID. Oh, we forgot even login also, right? Where is the login? After student name, login. I forgot to type. Yeah, mail ID and other. Just some numbers I am typing. Maybe the mail. Now just I am trying to insert this record. Now it is going to show an error. Here, what is the error? Just check it. Here, duplicate entry 187R121 per key student primary. Yes, yeah, this is already existed. So that we are trying to insert same. That is what enforcing means. Our constraints are enforcing. Understood? In the same way, if you want to update something already existing data of primary key, if you are doing same data trying to insert, that primary key is going to enforce, means it will be invoked, the data already existed, so that it never accepts the data duplication data. Are you clear? All of you clear?
Yes, sir.
Yeah. Now, the same way, when you go for update also, so this is also same option. If you want to update, if you want to update any data with primary key value, if you want to update, then also it will be show same error. If you want to update set column value of existing data of this primary key value, then that also going to show same error because already the data is available in the database. If you write update query, you will get same way. Are you clear? Are you clear?
Yes, sir.
Now, one more thing also I told you earlier. When you want to provide primary key and foreign key mechanism, here we have to create that mechanism for enroll table. Already we created a table. The name is enroll, and we are created the primary key of that enroll is student ID, and CID are the primary keys, and foreign key of SID references to the students. Here, when we are doing this, when we want to delete any record in a enroll table, you must be delete the record in the student table. And when you want to insert a record into the enroll table, that record, that primary key student ID record must be there in the student table. Here, this is what when we are going to define a association between two tables, that is students and enrolled, nothing but a foreign key constraint. This will be already you know very well. Yes or no? Yes or no?
Yes, sir.
If you want to, already I given this all these things, but again I am critically I am telling now. Select start from enrolled. Yes. Here now 1, 2, 3, 1, 2, 2. Here now if you want to insert a record here in this table, that SID value record must be there in the student table. Then only it is going to accept, because here we are created this enroll table as a foreign table, so that we are created foreign key, so that it will be verified and it will be done. So this is what exactly it is going to happen. Even if you want to delete a student record in a student table, that must be deleted by enrolled table, so that only you can going to delete that record in the student table. So this is vice versa. So that is what the foreign key constraint it is going to enforce when you are going to perform any data manipulation operation after after implementation of this foreign key of the tables. Are you clear? Already we are exercised all these things, even though I am showing now. Are you clear?
Yes, sir.
Yes, sir.
Now one more new task for you. When you want to specify that when a student row is deleted, for example, a particular student row is deleted, all enrolled rows that refers to are to be deleted as well. You know this statement already, just now I told you. Here, whatever the record you want to delete in a student table, that record you must be delete first in the enrolled table, later you delete in the students table. So this is the procedure, because there is a foreign key referential integrity is there, so that we need to do that process. Yes or no? Yes or no?
Yes, sir.
Yeah. Sure, but here now one more alternate I am telling here, but that when the SID column of a student row is modified, thus update is to be rejected if enrolled row refers to the modification students row. So this is you know already, when you want to do some update, that must be updated in the students, so that we can update in the enrolled table. Here for that we have one option here, because every time when you want to delete a one particular record in the student table, that must be deleted to the enroll table. Here every time you go to delete enroll table that record and come to student table, and you need to delete the thing. Means we have to apply 2 times deletion operation. Yes or no? For 2 different tables. Yes or no?
Yes, sir.
Yeah. Here
Sir,
to
someone is waiting, sir.
yeah, I accepted now.
Okay, sir.
Yeah. Please. Now instead of this, doing 2 times one particular record, if I want to delete, I have to delete enroll table. After that, I come to back student table and I have to delete. Instead of that, at the time of preparation of this enforcing integrity on enroll table, we need to write up to this same as it is. Here, earlier we have written the query, right? Here, SID, student ID and CID, and student ID, CID is the primary keys, and the grade, and foreign key, student ID references to the students of SID, this. After this, we need to write on delete cascade. Here, if you write, are you clear? Up to this, you know the query. Yes or no? Hello? When you want to write foreign key on enroll table, here this is the procedure you know already. Yes or no? Hello? Hello?
Yes, sir.
Yeah. Now, my solution is here when if you write up to this the query, here when you want to delete something in a student table, we need to delete enroll table that record, so that you go to student table and you need to delete the particular record. Here instead of this, every time doing a 2 times delete operation, there is a mechanism in our SQL that is on delete end of the query. You write end of after this referential integrity, you can write on delete cascade. Here, what is the meaning of on delete cascade? Means here when you are going to delete student enroll table, automatically it will be deleted in the its parent table. What is that? Student table. Here no need to delete 2 times. If you want to delete a record in the enroll table, automatically it is deleted in the student table. If you write on delete cascade, cascade is nothing but related table data also it is going to delete. Are you clear? You please try to execute these queries on your databases, then you can understand. Are you clear?
Yes, sir.
Here following of this same query, I am extending your on delete cascade. If you delete one record, that referential integrity student table record also, it is related record also going to delete directly. No need to write the delete query twice, because at the time of table preparation, we are given a command to the SQL database that is on delete cascade. The meaning is on delete cascade. If you do delete here, automatically it will be deleted in the students also. That is the meaning of cascade. Now, if you don't want to update something, you are going to update in the enroll table, the data cannot be updated in the its parent table, student table, then you need to write on update. Here, when on update means on delete means delete operation. On update means update operation. No action. No action means nothing will be happen into the student table. This is the meaning. On delete cascade, on delete update, or on update cascade, or on update no action, and on delete no action. Are you clear? So these are the 4 operations we can use. Are you clear? The information is clear.
Yes, sir.
So this primary key and foreign key, we can get only because of 2 operations, we will get some conflict. That is deletion and updation. For this, if we wanted to write only one time, it never affect to other table. We use cascade and no action. Cascade means that it will be same action will be reflected to its parent table. No action means same action cannot be reflected on the parent table. Then we can use on delete cascade, on delete no action. There are on update no action or on update cascade. Even you can use single operation also as per your requirement. Understand the meaning of these keywords? Enforcement of integrity constraints. Understand of these keywords? Cascade and no action. All of you?
Yes, sir.
Yeah. And even if you want to use 1 or 2 other things, set default. Here on delete, set a default. So if you fix default value, when we are going to delete something here, it is going to update default value in the parent table. Please try to execute all these queries. It will work, and you show the results in the next session, please. And on delete set null. Here, if you are going to delete enroll table, and it is going to update a null to the parent table, means student table. So these are the keywords we can use. delete, update. Here we can use update also. On update, set defaults. On update, set null. Here, set null, set default, cascade, no action. You know the meaning. Cascade means same action has to perform in the parent table. No action is nothing but nothing is going to done in the parent table. And set default means it is going to set to a default value in the parent table. And set null means it is going to set null into the parent table when we are going to perform your operation, either delete or update. Now understood all of you, enforcing of integrity constraints with additional features. All of
Yes,
you,
sir.
yeah. Now coming to the transactions and constraints. You know, when we are going to create a table, you know, just now I told you, here create table, student table, create table, courses. Then at the time of providing, creating this database, we can use here foreign key constraint so that our integrity constraints will be working. That is the meaning of transaction and constraints. You know very well. Now coming to the next topic, query relational data. Here, what is the meaning of query relational data? Nothing but select query. Already we are discussing select query. Here, how to write the select query? Select star from students. Here, select star from table name. You know, we have so many conditions under select query. We can use where clause under the select query and ordered by clause under the select query. Even in the where clause, we can use arithmetic operation, logical operations, and hello, are you there? And comparison operators. Almost we are already discussed about select query in the last laboratory. Here we can use all types of select queries here. Here that is nothing but a querying relational data. Means we are questioning the relational data. We are extracting the data from the database. That is what querying relational data. That is why you can write any one here. Select you can select the instead of star you can write column names also. I told you, and even we can use alias names also. For students have taken alias name is this, so that s dot s name s dot login from students is where s dot age is less. Already I shown all these things in the last laboratory. So many questions also I have given, so many exercises also I have given, and so many solutions also I provided in the last class. So that we can write all select queries under querying relational data. Are you clear now? Are you clear? Querying relational data is clear because already we know that. Yes or no? Hello. On Saturday we discussed all these querying relational data with practically. Yes or no? Hello. Hmm.
Yes, sir.
Yeah, what is going on? You people are not responding. Are you sleeping? Hello. Are you sleeping now? Hello.
No, sir.
Then why only you, Santosh, you only respond, remaining people? Maybe you are not sleeping, remaining are sleeping.
No, sir.
Ah. In the last lab, already we discussed about this querying, right? Select query.
Yes,
Yeah,
sir.
under this we can write all select queries, querying relational data. Okay? Is it okay? Under where clause, under order by clause, all these things. Some more things also there we will discuss. Okay, don't worry. We will discuss that also. Is it fine, everyone?
Yes, sir.
Yeah. The next important topic is logical database design. A very important topic, logical database design. Here, what is this logical database design? Here, I think all of you, maybe you are designed ER model. From ER model to you are converted relational model. Yes or no? All of you converted relational model from ER model in your laboratory. Second experiment. Yes or no?
Yes, sir.
Yeah, after conversion of relational model, now we need to design the logical database. Logical database is nothing but a SQL queries. Now, how to write SQL queries for that particular ER model? Now we are going to learn in this topic. Means here then we can implement all your databases, GR model databases. Now we need to convert logical database. You're using this today's class, it is going to help a lot for all your databases. So that please all of you carefully listen and follow and respond. Clear?
Yes,
Please
sir.
note it down also because a lot of your problems will be solved based on today's class. Because already you know SQL queries, already you know ER models, and conversion from ER model to relational model also you've done. But you don't know the logical database design, means queries, how to write, how to construct that entity to relation, how to construct that weak entity to the relation, how to construct total participation and partial participation to the relation, how to construct relationship set to the relation, means table. So this is most confusion things are there. Now, based on this topic, you can get more clarity so that you can use all SQL queries and you can convert your all databases to the logical database design. Is it okay? Now, all of you ready? Shall we? Very important topic in this unit actually. Hello?
Yes, sir.
Yeah. Please note it down and respond. If you are having any doubts, please ask immediately, please. Okay. Right. Logical database design. Already I told you the ER model is convenient for representing of initial and high level database design. We know very well. Now we are going to translate ER diagram into a collection of tables. Exactly. So that conversion is required. Most of the constraints and most of the SQL queries knowledge. Already we are aware of SQL queries because earlier we discussed so many data manipulation language and data definition language queries. So that we are having some knowledge on this SQL queries so that we can easily define the constraints and easily understand because already we know ER models so that easily we can construct the relational database so that before this topic I discussed about SQL queries DDL and DML. Here this is my intention why I skipped this topic and why I moved to the next topic, then you can understand. Are you clear now? Because
Yes,
this
sir.
topic now it is easy. Yeah. Right. Yeah, the first one, entity sets to table. Yeah, the first, yeah, if we are having one entity, then how to convert this as a table? Simple. Here, for example, this is the employee entity. We have only one entity. If you feel in your database ER model, the entity is like that. For example, I am telling, okay, in your database, you are having different entities, different attributes. Only some small things I am going to take and explaining. So based on that, you please define and design your relational model. If you are having any doubts, please contact and please work on. Then only you can understand, please. And note it down. If your entity is like this, your employee is entity and SSN is a attribute and which is a key attribute. Yes or no? Have you observed underline of SSN? Hello?
Yes, sir.
Yeah, name and LOT means location. Three attributes are there. Now I converted this into the relational model. You know how this you done already. From entity to relation, how we are going to convert already we done. Yes or no? Yes or no?
Yes, sir.
Now I am going to implement a logical database design. For this, here how we are going to represent a logical, nothing but a SQL query, how to write. Here simple, here creating of table, you know very well, same query I am using. Create table, table name. Create table, table name. Here the first column is SSN I'm taking what type of data it is. You know, you can define the data, and based on data, you can write a data type. Here I have taken char, or you can take varchar as also as per the requirement, and we need to specify, analyze here how much SSN means how much a number of characters it is going to have. That many number of characters you specify as a size. Next one is the name. You can take it char and size, and location is nothing but any LOT, maybe the number or flat number or something. Okay, you can write that, or you can take, if you take more attributes, then you can add more columns here. And already I told you earlier, this SSN is a primary key, so that you can write this primary key after the SSN data type also, or separately also you can mention primary key of SSN. So this is the way of creation of logical database. Already you know this. Earlier also I told you very clearly this creating of table with primary key. Clear? The first one is clear. Entities is to tables. Please quickly.
Yes, sir.
Yeah, we have 7 categories. That's why we have to finish it. All categories, then we go for, we can understand everything in the same class. The next class again you will get confused. So coming to the second category, relationship sets without constraints to table. Here without relationship set is nothing but what? So what is the meaning of relationship set? This is the relationship set. Means employee works in department, employee works in location. Are you following? This is a relationship set. Yes or no?
Yes, sir.
Now we know how to convert entity to the relation. There we know how to convert entity set employees to logical database relationship. How to convert table. This employee we know as per the first case. Department also we can convert. Location also we can convert. Yes or no? Because this is entity sets to tables. We converted. So same way you can convert first 1, 2, 3 tables. Yes or no?
Yes, sir.
Yeah, the fourth one is relationship set. We don't know how to convert this relationship set as a table. Now we are going to learn in this topic relationship sets to tables. Are you clear? Are you
Yes,
clear?
sir.
And without constraints means without constraints. There is no conditions. When I am converting this relationship set, this relationship set is not having any condition. Next, topic is with constraint. I will tell you. Means with condition is nothing but a cardinality. 1 to n relation, n to 1 relation. All this is the condition. Now without condition. Here I am not mentioning any cardinality. If you are not mentioning any cardinality, then how to convert this relationship set? Anyway, 3 tables already there. The fourth table is we are implementing from relationship set. How to implement? Very simple. So these 3 tables you can convert very easily. Yes or no? Yes or no? Hello?
Yes, sir.
Yeah, now our agenda is relationship set. We are going to convert this relationship set to table. Here, before conversion, we need to know some of the important points. Please note it down. Sure, a relationship set like an entity set is mapped to a relation in the relation model. To represent a relationship, we must able to identify each participating entity and give value to the descriptive attributes of the relationship. Means each participation entity means employee works in department. Employee works in department. What are the participation entities? Employee works in department. Here the participation entity, here what is that? For workshop works in a relationship set, your employee works in department. Here, for example, CSC department, if you take, this is a CSC department. Here, the department ID must have the employee also. Yes or no? So that we can ask that employee is a CSC or not. So that this DID is a participation attribute or not.
Yes,
Hello?
sir.
And department. Here, if the employee is in the department, this department that employee is having SSN or not, means employee ID is there or not for that particular department faculty.
Yes, sir.
Yeah, that's why this SSN is a participation attribute. Yes or no? Yes or no?
Yes, sir.
Now, employee works in locations, means address. Location means address is nothing but a here. SSN again it is a participation. Location nothing but address means what is that? Second floor. CSC department is at second floor B block. Here like that address. So that this address is a participation attribute or not from employees works in department. Address is a
Yes, sir.
participation. Yes. Now the first thing is what you have to do, able to identify each participation entity and give values to the descriptive attribute. Here, descriptive attribute means already I told you, employee works in location, employee works in department. If this is a since, employee works since, here since is there at relationship set. Here the attribute which is assigned to the relationship set, that attribute is called as descriptive attribute. Means when we are going to define a table from the relationship set, here please note it down. Three parts we need to identify. First two parts we need to identify. One is participation attributes in the entities, and the second one is descriptive attributes. These are the two things we need to remember. Are you clear? Are you clear? Hello? Are you clear?
Yes, sir, clear.
Yeah, that participation attributes are primary key attributes of each participation unit set. Exactly. As a foreign key field. Yes, exactly. Here, when we are going to observe that participation attributes, that is a primary key. SSN is a primary key of employee. Yes, it is a participation. Here, DID is a primary key of a department. Participation. Here, address is a primary key of location. Here, participation. And from here, this is a foreign key. From here, address is a foreign key. From here, this is a foreign key. From here, this is a, that is what? Here, that is a first point we must be remember. Are you clear this?
Yes, sir.
The next one is the descriptive attribute of the relation. Already I told you this is a descriptive attribute. These three are more important when we are going to prepare a table for the relationship set. Now I am trying to prepare a table for the relationship set is works in, create table works in. So what is the participation attributes? SSN, yes, created. Are you clear? Are you following?
Yes, sir.
First column is SSN, second column is DID, please observe, and third column is address. Here I am not taking the things, participation attributes I have taken. First phase, what we have to consider? Participation attributes. Done? Yes or no? Means all primary keys of participated entities. Done? SSN, DID, attributes. Done?
Yes, sir.
Along with that, we need to consider descriptive attribute. What is a descriptive attribute? What is a descriptive attribute?
Since.
Since. Okay. Now we have taken four columns. 1, 2, 3, and descriptive along with descriptive attribute 4. If you don't have any descriptive attribute, you no need to consider here. Only you need to consider participation attributes. Nothing but primary keys of participated entities. Understand? Understand? If you have
Yes, sir.
descriptive attribute, you can include. Okay. Now after this, we need to define a primary key because all these are keys, right? Then we have to define the constraint also. So that's why your primary key of what are the primary keys? SN, DID, address. Yes or no? Yes,
Yes,
or
sir.
no? Now primary keys we are defined. Now after that we need to define a foreign key also. Why? Here this DID is a foreign key of employee. Accepted? Accepted.
Yes, sir.
This SSN is a foreign key of department. Yes or no? That's
Yes,
why
sir.
we need. That's why we need to define simple foreign key SSN references to employees. Foreign key address references to locations, foreign key DID references to department. So like that, we need to define foreign keys also. So this is what creation of table from the relationship set. Understand? Very easy actually, if you understood. All of you understood? All of
Yes,
you
sir.
understood? Yeah, please try to make it these things into your database. Already you people are converted relational model. Now you define your database as a logical database with help of this knowledge. Clear? All of you clear this? All of you clear this? Hello? Hello? All of you clear this?
Yes, sir.
Time is running, please quickly. Now, if your entity, only one entity is there, that is a only one entity. This is a unary relationship set. That is a reports to only one entity is participating. For that, how to define? Very simple. Your reports to is a relationship set. If you are having your database like that, we don't have such type of databases. But if even though I am telling, if you are having your database having only one entity, association itself only, that is a unary relationship set is there for your database, then how to implement logical database? Yes, create table. Here this is a relationship name reports to here. Then you have to take SSN. Okay, SSN. You have to take as this because SSN for supervisor because employees supervisor reports employees subordinates reports to supervisor reports to subordinate. So both are employees. That's why I have taken this SSN for sometimes supervisor, sometimes subordinate. So that supervisor SSN and so that subordinate SSN and both are the primary keys I have taken and I am going to take in as a reference. Simple, same thing, nothing I have changed, same thing. Understood? But we never use this type of unary relationship set because nowadays we are having so many entities. Okay, but even though I'm giving the idea, if any exam or any placement people will ask, you can understand very easily. Are you clear this?
Yes, sir.
Yeah. Now third one, translating means extracting or translating relationship set with key constraints. Already I told you that this is without key constraints, without constraints. Now here relationship set with key constraint. Now we have to use some of the constraints. What is that? Here many to one relationship set. Yes or no? Yes or no? Hello? We are going to convert relationship set to the table with constraints. If you are having constraints, that is a many to one, one to many, many to many, like that. Are you clear?
Yes,
All of
sir.
you clear? Yeah. For that, how to do? Very simple. Same way, you have to take it SSN, DID, and SIDS. Correct? SSN, DID, SIDS. Up to this, correct? All of you clear? All of you
Yes.
clear? All of you clear? Up to this, all of you clear?
Yes, sir.
Yeah, we need to take participation attributes and descriptive attributes. Up to this clear. Now it is a many to one relationship. Here many to one. Here many to one means there is no chance of many primary keys. Yes or no? There is a chance of only one primary key. There is no chance of many primary keys. That's why we can define primary key for DID. We cannot define primary key for SSN. But here we are not specified any constraint so that we are considering one only so that SSN DID address as a one primary, all are primary key SSN DID address. So that is what. But comes to here key constraints, then we need to define only one primary key which is DID because it is a only one is going to participate all time. So that's why here only one means primary key is having only one time in a table here only one primary key is there in the table. More than one is not possible. So that we need to write primary key of DID. Are you clear now? Are you clear now?
Yes, sir.
And the remaining things are same. What is that? For SSN, DID is the foreign key. For DID, SSN is the foreign key. So that we have to define that. Foreign key of SSN refers to employee. Foreign key of DID refers to department. Clear? Same story. Only these things we have to do it. Means cardinalities only we have to add here. Clear?
Yes, sir.
Right. Next one, translating relationship sets with participation constraint. Participation is nothing but total participation and partial participation. Yes or no? Total participation means all the entities of the entity set is going to associate with to another entity. Partial participation is nothing but only some of the entities are going to participate to the entity set. That is the partial participation. Are you clear? Are you clear?
Yes, sir.
So, for example, employees manages a department. All the employees are going to manage as a department. All the employees are means all the faculty is going to manage to the department. All the faculty are managing to the department.
No, sir.
No, only some of the faculties are managing the department. Maybe HOD or in charge HODs are managing to the department. Normal faculty cannot manage the department. Yes or no? Yes or no?
Yes, sir.
And employees works in department. All the employees are works in department or not? All the employees are going to work, right? All the employees are working in the department. All the employees are going to work to the department or not?
Yes, sir.
Means all the employees are participating for the work relationship.
Yes, sir.
Yeah, that's why it's a total participation. Understand? Understand? Already I told you bank, borrowers, loan. Here all the borrowers are going to take the loan, but all the customers are not borrowers. Yes or no? Same example I told you. This is another example. Are you clear?
Yes, sir.
Now for this total participation and partial participation, if it is there in your ER model, then how to implement the table? Very simple. You know, here we need to consider here from department only. Here not for employee because department always it is a total, right? So that's why here we have to consider department manager. Here department manager, not employee manager. For department from department itself you have to do it. So that's why DID is the primary key for this relationship. As a department, we have to consider DID, DNAME, and budget. All the attributes of department we can include. All the attributes of department we can include, and right DNAME and budget. Okay, and we can take it participation attribute. That is a SSN, which is not null because compulsory. It is not a primary key, but it is a key, so that we can use not null. Otherwise, also we can do it. And descriptive attribute. Are you clear? Are you clear? Because all the employees are not managing to the department. Only some of the employees are managing the department. So that I never take employees under consideration with managers relationship set. When I am taking managers relationship set, then I am going to consider a through department. So that create table department managers. Here I have to take only department related attributes so that the DID and DNAME, budget, and participated constraint is SSN and descriptive attribute of managers SSN. Are you clear?
Yes,
Are
sir.
you clear? Sure. After that, here this SSN is a what is the primary key here? DID is the primary key. You know very well. And we have to reference SSN is a foreign key. So that foreign key SSN refers to employees. This is a common thing, you know. Primary key and foreign key you need to specify. You know, primary key is DID, and foreign key is SSL, just your references. Done? Up to this clear? All of you clear? Very simple. Only the thing is total participation and partial participation. From employee managed to department, all employees are not managers to department. Only some of the employees are managers to department. So that I have taken this entity, department entity attributes, I'm considering to the managers relationship set attributes. Simple. All attributes of department attributes I'm considering to the managers relationship set, because here this is a partial participation is there, so that I am considering here this whatever the partial is there, that attributes I am taking under consideration. Along with that, your participation attribute, that is SSN. After that, I define primary key DID and that is foreign key is SSN. Same way, I can take it as considered this SSN as a foreign key. Are you clear? Up to this, all of you clear? All of you clear?
Yes, sir.
Yeah. Now, on delete no action. On delete no action. So after that, I need to write on delete no action. Sir, if I am going to delete any employee in the department, sir, it never be affected to the employees, because sir, I removed one faculty from the department. Sure, but college is never going to terminate the faculty. College will use the faculty into the other department, maybe the HNS department, or maybe the placement department, or maybe the other research department, or etc. etc. They can use, because here I am not using that faculty in the department means he is not an employee. He is not in the department because it is a partial part. I told you, all employees are not managed to department. So that is what. Sure. Some of the, for example, director Ali Beg sir is there in the mechanical department, but they are not going to teach subjects and they are not taking any classwork in the mechanical department. But they are in the college, means employees. So that when I am removing those things, faculty in the department, mechanical department, they are not going to delete in the employees. They are available. That's why there no on delete. Here any delete is going to happen and no action in the parent. So this is the meaning. Are you clear? Are you clear? That you need to analyze and you need to write as per the things. Are you clear?
Yes, sir.
Right. For example, if you want to write total participation, employees works in department. If you write works in relationship set, how to write? Tell me anyone. How to create table for total participation? Employees works in department. How to write? How to write this works in? What is the query? Tell me. To convert works in relationship to table. How to write a query for this?
Create table.
Create table. Table name is works in. What are the attributes you need to take it?
DID, SSN.
SSN, DID, and since.
Since.
These three things will come.
Respective.
And primary keys of SSN, comma DID. Yes or no?
Yes, sir.
And you need to reference reference DID, and you need to reference to the SSN. Yes or no?
Yes, sir.
So this is what exactly we need to do. Okay, that is a total participation. The partial participation, we cannot we do something in the department, we cannot do in the employee. That's why we need to write on delete no action also. Understand now?
Yes, sir.
Yeah, please. Now, fifth category, translating weak entities. Here already we know weak entity and strong entity. Here weak entity is nothing but always that entity is depending on the strong entity. For example, employees policy department. Here means here department is a weak entity of employees. Why? Because here we know policies That policies is given by the employees. Here, compulsory the department is must be uh, uh, depending on the employees' policies. Nothing but whatever the college is going to provide policy, here you must work from home only for this month. Then that policy is generated by the employees. The department obviously it must be followed. That's why here something is going to happen. For example, any inspection is there or first mid examination they want to conduct. The policy is made by employees, department undergone with that. So whatever the policies come, compulsory department is going to follow that. That's why department is a weak entity, employees is a strong entity. Understand? Are you clear?
Sir,
Hello?
can you repeat again?
Here, whatever policy is nothing but any decision. For example, 17th onwards, first midterm examination, they wanted to conduct, they released one schedule. The department has to follow that particular schedule without any anything. Compulsory, they need to follow. Here, college wanted to recruit 20 faculty, then department has to take up the things. Here, the college want to, any employees they wanted to relieve, then automatically the department is going to do that process. College has to take work from home or maybe the online class work, then department has to take as per the policy. So that is what here always, here whatever the policy is come, department has to follow. Means the department is a weak entity, employees are the strong entity. Correct?
Yes, sir.
Yeah. So that's why here if you take employees, the SSN is a primary key and department P name is a partial key because weak entity primary key is called as partial key. Please remember. Here partial key must be a dotted underline. Are you clear? Are you
Yes,
clear?
sir.
Yeah. Here now how to define or how to design a table from the weak entity sets. Very simple. Here weak entity sets are going to participate in the relationship. Generally we know how to define the table for this employee entity, how to define a table for this department entity. But we need to define a table now for the relationship set because that particular weak and strong will come from relationship only. Here I am concentrating on relationship only. Only first case we take an entity, remaining all the cases on relationship set only. Please understand. Because things are going to change at the time of relationship set only. Yes or no?
Yes, sir.
Yeah. So that's why here now I am creating a table for the relationship set of policy. Here now I am taking department under consideration because this is a weak entity. A strong entity always we can take all the things, but weak entity is the problem. It must be depending on employee. Means something is going to happen, it will be reflected. Something is going to happen here, it will be reflected. Compulsory, it must be followed. So that's what we need to define a relationship set to table. We must consider weak entity under the consideration because it is must be a dependent entity. So that here we need to consider this. So that we need to consider these weak entity attributes under the department policy entity set table. That is P name, the partial key, and age, two attributes. Along with that, here any descriptive attribute is there, but a relationship set, you can take it. If it is not there, no need to consider. So then participation attribute, what is that? SSN, that is must required, and primary key, your P name as well as SSN, and foreign key is, very clearly, SSN is a foreign key of department and a reference to employee. And here this is very important, on delete cascade. Anything you are going to delete, it must be reflected. This is what exactly on delete cascade you need to write in this weak entity participated in the relationship set, so that it will be clear. Otherwise, if something is going to happen, it must be reflected. That will be done only on delete cascade condition. Now clear? All of you clear?
Yes, sir.
Yeah. Now 6th, 7th is very easy. I will finish. Almost time is over. What is the next hour? Tell me. Who is the next
DM.
subject? Huh?
DM sir, Nagesh sir.
Yeah. Okay. You tell him, sir, 5 minutes is delay. You tell him, no problem. Here, sixth one is translating class hierarchy. Here, I don't want to discuss much because the translating class hierarchy. If you designed a class hierarchy like this, person is a employee, person is a parent. There are two ways we can implement a table for this uh, class hierarchy. How? I will tell you. Here, one is we can define this is the table. Person as a table. Here, how to write, you know. Entity to table creation, you know. Yes or no? First topic I told you. Yes or no?
Yes, sir.
So that is what? We are creating three tables for each of the entities, person, employee, and parent, the attributes of these entities. They're like this. This is one table. This is another table for employee. This is another table for parent. Like that, we can create it here as it is. Understand? Understand?
Yes, sir.
Here another approach is here only two tables. Here only two. Why two tables means? One is employee table, another one is the parent table. When you are creating employee table, you can take all these attributes of person to employee table. The same way, all these attributes you must consider into the parent table. Now only two, if you are having two options, when you are going to create a tables for the class hierarchy, first option, individually create separate tables. Here three are participated in the class hierarchy. You can create one table for this, one table for this, one table for this. Over. How to create? You know the first case, how to create your diagram to relation, entity to the relation, entity to the table, you know. Yes or no? Yes or no?
Yes, sir.
Second option, or you can go for second option, means only I want to create two tables. Yes, you can create only two tables. One is employee table, another is parent table. When you are creating, all the attributes of person you include into along with employee attributes for first table. For second table, all the attributes of person attributes you must include in the parent table. The two tables are enough because these attributes are derived to its derived attribute entities. Correct? Now understood? Hello? This is a parent class, this
Yes,
is a
sir.
derived class. Clear now? Clear now? Class hierarchies creating table is clear?
Yes, sir.
Yeah. Last one is ER diagram with aggregation. So already we know aggregation. Here when we are having more than one relationship set for entities, we need to provide the aggregation. Already this example I discussed, projects, sponsors, department. So this is one aggregation. Now employees monitors projects, employee monitors some departments. Yeah, this is what exactly now we need to create. Here for this, what should we do? Very simple. Very simple. We need to create separately. Here projects is one entity, means table, and department is another table. Now sponsors is another table. Here how sponsors will come? To consider PID, DID, since, and primary keys of PID and DID, references PID to DID, references to DID to PID. Yes or no? Yes or no? Hello? Hello?
Yes, sir.
The next one is fourth table is employees. You can take it employees table from the employees entity, and fifth one is the monitors. So how to take the monitors as a fifth table? Very simple. You consider SSN is a participation entity and PID is a participation entity, DID is a participation entity. Along with that, you consider this until is descriptive attribute. Here four attributes, 1, 2, 3, and 4 attributes. After getting 4 attributes, then we need to write enforce in foreign key constraint is primary key constraints are what? SSL, PID and DID, and foreign key constraint SSL to PID, SSL to DID. Are you clear? Means you will get 5 tables from this aggregate operations. One is 1, 2, 3. 3 tables from entities, 2 tables from relationship sets. Clear? All of you clear?
Yes, sir.
Yeah. So this is what 7th one. What is that? Translating AR diagrams with aggregation. If you are having such type of mechanism, please use this mechanism. Very easy. Now I hope everyone is understood, right? I hope everyone is understood this.
Yes, sir.
Yeah.